Hello student, the question says if the bar magnet in exercise 5.13 is turned around by 180 degree, where will the new null point be located? So there was a mistake when the NCERT textbook got updated. So they did not change it into 5.8. This is not 5.13. So the first mistake is it is supposed to be 5.8. So when the bar magnet in exercise 5.8 is turned by 180 degree, where will the new null point be located? We have already solved this in detail and I have explained everything about 5.8 in detail. You can watch the previous video. For now, let us assume you already solved this 5.8, but I will give a brief introduction to what happens in 5.8. So in 5.8, we have the Earth's magnetic field in this direction. So imagine that this is my Earth's magnetic field and my bar magnet is placed in this way, opposite to the direction of Earth's magnetic field, and we get null point somewhere here at 14 centimeters. In the question, you can see the null point is at 14 centimeter from the bar magnet. So from the center of this, if we try to measure the distance of the null point, let me call this as A, and this A was 14 centimeters, and we were asked to find exactly at same A, what will be the magnetic field on the axial point. So this was the question that we were asked to solve. And why do we get the null point here? Because for a short bar magnet, the magnetic field on the axial line will be in the direction of bar magnet, and the Earth's magnetic field at this location, as you can see, that's magnetic field is towards the left. Both these would counterbalance each other. Once these two counterbalance each other, we got the null point. Now, for the same scenario, what happens if you rotate it by 180 degree? Now, let us say I rotated the magnet by 180 degree. Now, my magnetic field lines are aligned with the Earth's magnetic field. Once my magnetic field lines are aligned with the Earth's magnetic, when we rotate the magnet by 180 degree, the magnetic field due to the bar magnet, the magnetic field created by our bar magnet will be along the same direction as the Earth's magnetic field on the axial line. So on the axial line, you cannot get a null point on the axial line, because if I select a point P here, the magnetic field due to Earth is also towards the left and due to bar magnet is also towards the left. So both would add and we cannot get a null point. But as we have studied on equatorial line, the direction of magnetic field due to the bar magnet would be opposite to the direction of magnetic moment. That means due to the bar magnet, the magnetic field would be in this direction. So this is the direction of magnetic field due to the bar magnet. Now, since this is the direction of magnetic field due to the bar magnet, and due to Earth, let us say at this location, we can get a null point. Imagine that this is the point where we can get a null point. Let me call that as point Q. So this is the due to magnet, and this is the magnetic field due to Earth. So when both are balanced, we get a null point, and let us assume this distance is X. I will take a little information from the previous question. In the previous question, he has given if the magnet is aligned in this way, if our magnet is aligned in this way, we get a null point at 14 centimeter. What does it actually mean? So in previous question, we got mu naught by 4 pi into, on the null point, the magnetic field formula is 2m by x cube, where x is the value, is equals to magnetic field due to the Earth. The value of the x is given as 14 centimeters. Let me call that as A. So mu naught by 4 pi. So 2m by A cube is given as B of Earth. Now we have rotated our bar magnet by 180. Since we have rotated our bar magnet by 180 degree, let me call this new position as x2. So in this problem, at null point, on equatorial line. Remember, we cannot get null point on the axial line. We can only get null point on the equatorial line once we rotate it by 180 degree. So null point on equatorial line. So we get magnetic field due to magnet must be equal to magnetic field due to earth. What is a magnetic field due to a magnet on an equatorial line? We know the formula is mu naught by 4 pi m by x cube. If x is the distance, this must be equal to b of earth. And in place of b of earth, can't I substitute mu naught by 4 pi 2m by a cube? So let us substitute that, which is equals to mu naught by 4 pi 2m by a cube. So once we have this, we can cancel mu naught by 4 pi, mu naught by 4 pi, m and m I can cancel. So we basically get 1 by x cube equals to 2 by a cube. So x value would be a cube by 2 whole power 1 by 3. So we basically get a by 2 power 1 by 3. A is given as 14 centimeter in the question. In the previous question, if you see, the value of A is given as 14 centimeter. So 14 divided by 2 power 1 by 3. So we need calculator for this. So let me use it. So 2 power. So this value is equals to 11.11 centimeter. So when we do 14 by 2 power 1 by 3, you are getting 11.11 centimeter. So at this distance, if you rotate it by 180 degree on the equatorial line, a new null point would be located. And let me tell you, the null point is not only in the upward side, on the downward side also, at the same distance x, we get a null point. So don't think that null point is only above the magnet. Even below the magnet also, this is the direction of magnetic field due to the bar magnet, and this is the direction of Earth's magnetic field. So both above and below it, at this distance, where 14 by 2 power 1 by 3, we get our value. Hope you understood how I have solved. But to understand what we have done in the previous problem and what is the Earth's magnetic field, do watch the previous video also. It will help you understand this concept better. Thank you.